Today we'll be solving problem number 20 from the 2017 AMC Chem B. Let's jump into it. The number 21 factorial equals has over 60,000 positive integer divisors. One of them is chosen at random. What is the probability that it is odd? So this problem seems daunting because you see this magnanimous number, but the problem is actually very simple if you understand the principle and kind of just it's kind of like a formula because you have to know how to find how to prime factorize factorial. I'm going to show you the formula. So basically, in order for you prime factorial, I'm going to write this summation form. So basically, the number of prime factors in a factorial is equal to the summation for some variable I goes to infinity. We take the floor of n divided by p to the ith power. So what does that mean, Tyler? Okay, that basically means that if we have any sort of factorial, let's just say we have 4 factorial. Okay, we want to see the number of factors of 2. Number of factors of 2. Okay, basically what we do, we plug in the formula. Basically, n is 4. So we take 4, and then we divide that by the priming one for 2 to the first power, and then we're gonna add 4 over 2 to the second power. And this is when I mean over, I mean like the 4. And we continue, but the thing is, when you do 4 over 8, the floor is out to 0. This time we're all gonna 4 to 0. So it's simply just 2 plus 1 and equals 3 factors of 2. 3 factors of 2 in 4 factorial. That's what it means. Really simple. We're just gonna apply this formula to 21 factorial. So we'll see that, okay, 21 factorial will have 21 over 2, which is just 10, plus 21 over 2 squared, which is just 5, plus 21 over 2 cubed, which is just 2, plus 21 over 2 to the 4th, which is just 1. So we have a total of 18 factors. So that's just 2 to the 18th. And then for factors of 3, we'll have 21 over 3, which is 7, 21 over 9, which is 2, and then 21 over 27 is just going to continue looping to the floor of 0. So it's just going to be simply 3 to the 10th. Okay? And then 5 is just going to have 4 factors, because if we square it, get 25 which is less than 21, therefore it's going to floor to 0. And we have 7 cubed, and then we have 11 first. What else we have? We also have 13 the first, 17 the first, 19 the first, and that's it. Okay, that's it. That's a prime factorization of 21 factorial. Very simple, right? So, we notice that if we want to have an odd number, we have to totally subdue subdue any sort of 2's in our number. We have to completely rid of the 2. Basically, we have to choose from any sets in these numbers. And let me tell you, the number of factors, or rather, number of divisors or factors, or whatever, number of factors or divisors in a number. Basically, say I have a number like e sub 1 p to the 1 times e sub 2 to the p to e sub 3 to the p sub 3. Basically, the number of factors is just p sub 1 plus 1 times p sub 2 plus 1 times p sub 3 plus 1. Because we always have to take into account the fact that there's like an n to the 0 power. And what does that mean? Like, for example, let's say I had a number like 2 cubed times 3 first times 4 squared. Or sorry, times 5 squared. Right? The number of factors this would have was like 3 plus 1 is 4 times 1 plus 1 is 2 times 2 plus 1 is 3. We're going to have a total of 24 factors, right? So the number of factors in this equation using that formula, solely based off that, is just going to be 11 times 5 times 4 times 4 times 2 times 2 times 2 times 2. And then we're going to divide this by the total number of factors, because we want the probabilities. That's like the successful cases that we want, and the total amount of cases. So 19 times 11, and we can basically continue this. We can write it out. 5 times 4 times 4. 5 times 4 times 5 times 4 times 2. 2 times 2 times 2. So now this is all going to cancel. We're left with 1 over 19. The answer is B. Very simple.